Assalamu alaikum students. In today's lecture we will study about a very important topic, that is normalization, and also we will study the first normal form and second normal form in details. We have already studied about the anomalies in database and then functional dependencies in the databases. So once you know these, then normalization becomes easier to process and to understand. These are the objectives of our today's lecture. At the end of this lecture, you will be able to know the possible errors and loopholes in an unnormalized database. At initial stage, when we design a database that is formed as the basic sketch, so that might be unnormalized, so we need to process all the design tables and restructure the entire database to make it into a normal form. Then we will look into the importance of normalization, so you will also understand the importance of normalization. After that, we will look into the normal forms. There are various normal forms, and we will study only the first normal form and second normal form in this lecture. The rest of the normal forms will be studied in the coming lectures. So these are the contents. Initially we will study about the normalization. What is normalization? Why do we need normalization? Then the process of normalization, then the normal forms. These are also referred as levels of normalization, and then we will study the first normal form and second normal form. So we will study about the first normal form, its process, and then what would be the problems in first normal form. Remember that normalization needs to be processed through several levels. Means that you must have at least third normal form or BCNF. So first normal form is not sufficient to remove the redundancy or anomalies in a database, so definitely we will have some problems in the first normal form. After that we will need second normal form. So for second normal form we must also understand the functional dependency, particularly the partial functional dependency among the attributes. And also at the end of this lecture we will look into the problems in second normal form. So normalization is a database design technique, and in this technique we organize the tables. Actually we decompose the tables to reduce the redundancy and also dependency of data. Actually we do this to eliminate the repeated data, to ensure that the data is stored logically and there is no such anomaly, or the anomalies are reduced in the database. Normalization is a process to evaluate and correct table structures to minimize data redundancies by reducing the likelihood of data anomalies. The normalization process involves assigning attributes to tables based on the concept of the relational database model. The process of normalization doesn't mean that we delete some data. Actually we delete the replication of data, or simply you can say that we eliminate redundancy in the database. So once the data has been normalized, it would give the same results as we get in the beginning or from the unnormalized data. But in the case of normalized database we will have a minimum level of anomalies, and also there would be lack of redundancy, or there would be minimal redundancy in the database. Actually, as I told you, that normalization is a process, and this process involves the restructuring of tables. Means that we decompose different tables due to some rules, so that we eliminate redundancy among the attributes values in different tables. Actually when we properly normalize a database, it must have the following characteristics. The first one is scalar values in each field. If you remember, in the ERD we used a multi-value attribute. So in case of a normalized database, in the tables each attribute must have a scalar value. There wouldn't be any multi-value attribute, and there would be absence of redundancy in the tables. Then minimal use of null values on all the tables. We will try to avoid the null values, and also loss information will be kept at minimal point, and there would be no repetition of data in the database, or kept the repetition at minimal level. Now we have the process of normalization. In normalization, what we do first, we eliminate repeating groups, eliminate redundant data, then eliminate columns not dependent on key, isolate independent multiple relationships, and the last thing is isolate semantically related multiple relationships. For the first point, we make a separate table for each set of related attributes and give each table a primary key. And then for eliminating redundant data, if an attribute depends on only part of multi-valued key, remove it to a separate table. For the third point, if attribute do not contribute to a description of the key, remove them to a separate table. Then in case of isolation of independent multiple relationships, no table may contain two or more one-to-many or many-to-many relationships that are not directly related. And in the last case, there may be practical constraints on information that justify separating logically related many-to-many relationships. Actually, these all involve the levels of normalization or the normal forms of a database. These all will be discussed in details in the coming lectures in the normal forms. Like for the first one, we will define the first normal form, and you will get a complete description about this point with some examples. Then we have levels. Actually, there are 6 levels of normalization, and also we can say that the 7th one is the domain key normal form. We have first normal form, then second, third, and this one is 3.50. Actually, in most of the cases, when we get the third normal form, this normal form is achieved automatically, but in some cases we may need this BC and F. Then with each level, the redundancy level is reduced. Like in first normal form, the redundancy would be higher, and in second case it would be reduced but still higher than third normal form. Similarly, when we go through these normal forms, the number of tables will also increase. In case of first normal form, it would be less, but as the levels are increased, the number of tables will also increase. As we know that this is the process of decomposing tables, so in each level we will decompose a single table into multiple tables, so the number of tables would be increased. Once the tables are increased, then definitely we will connect these tables by making some relationships among them. So due to that thing, we may face complexity. So we can say as the levels are increased, the complexity is also increased. Each higher level is a subset of the lower level in case of normalization. For if we need a database to be in a particular normal form, then it must be in the previous normal form. For example, if we need second normal form for a database, then it must be in first normal form first, then we will be able to convert it or to process it to be in second normal form. So these are the levels. In first normal form, we will remove the multi-valued attributes. Actually, we will give separate rows to each value in a multi-value attribute. In second normal form, we will remove partial dependencies. We have already studied these dependencies in our previous lectures. Then in third normal form, we will look into the transitive dependencies, and in BCNF Bayes code normal form, the determinants will be checked and we will check the candidate keys, and in the rest of normal forms we will check the multi-value dependencies among the attributes. In today's lecture, we will study about first normal form and second normal form only, and the rest would be studied in the coming lectures. So the first normal form is actually a normal form in which all the attributes will have atomic values, means that there wouldn't be any multi-value attribute. If you remember the ERD, we used multi-value attributes. Like here we have skills, so this single attribute can keep multiple values. So this is actually initial stage of database, and this is only a design, so we can keep multi-value attributes here in ERD, but when we design the database and want it to be in a normal form, then we must remove such type of attributes, and we will try to keep these multi-values in separate rows. So a table is considered to be in first normal form if only scalar values are present in all the fields, means there is no multi-value attribute, and the records need to be unique too. The main objective of first normal form is to permit to be queried and manipulated using SQL. Actually, when we process the tables through SQL, we need atomic values under each attribute. So if there are multiple values under a single attribute, then we may face some errors or problems in our SQL query results. Now we will study some examples and check that why the tables are not in first normal form and how can we convert the unnormalized tables into first normal form tables. So this is the first table. It is about the record of books. Here we have ISBN, title of book, the author name, author phone, publisher name, publisher phone, and price of book. So if you look into the table here under author name, we have multiple values under one attribute in a single row. Similarly, for author phone we have multiple values, so we can say that the author name and author phone both are multi-value attributes. So due to these values, we can say that this table is in unnormalized form. It is not in first normal form. So the rule says that the multi-value attributes must be scalar and there must not be any multiple values under columns or under attributes. So we can convert this table into first normal form. Simply we need to split the non-atomic values. Like here we have 3 values, so what will we do? We will generate 2 new rows for the rest of the 2 values. The first value will keep the same row and 2 new rows will be used for the second and third value, and rest of the items will be repeated. Like here, this item will be repeated for sleepy, for snoopy, and for grumpy. Balloon will also be repeated. We can see these values here, like here these are repeated, and here we have now scalar values. The phone number is also not repeating, so these are now atomic values, and rest of the values are now repeating. So instead of using a single row, now we have two more rows, so these two rows are actually added. So in case of second record, we need a new row, and since there were two values, so this one kept its own row, and for this Smith we created a new row. Rest of the items are repeating. So this table has been converted into this table. Now this table is in first normal form. You can look into these two tables. This one is unnormalized and this one is now in first normal form. Then we have example number 2. Here we have some attributes. The first one is module, then department, then lecturer, and then text. Actually it is about studies, that which module is offered in which department, and which module is taught by which lecturer, and which texts are followed by the lecturer in a module. So now if you look into this table here, under texts we have multiple values. For M1 we have T1 and T2 by L1. Similarly for M2 we have T1 and T3. So these are multi-values, so the texts is a multi-value attribute. So we will do the same thing. We will create new rows and we'll split these values into atomic values to scalar values. So here we have M1, so this one is actually added for this T2, and similarly in the second row we added M2 again for T3, and also for M4 we have this one is actually for T1, and this new row has been added for T5. Now this table is now in normal form. Then we have example number 3. Here we have some data about the employee. We have employee ID, employee name, address, and employee mobile. Now if you look into the mobile attribute or this column, we have multiple values here. So this table is now unnormalized. If you want this table to be in first normal form, then we must remove this additional value and we'll give a new row for this value. So now here you can see that this 102 is actually repeated due to this value, and under employee mobile now there is no multi values. Similarly for 104 we added a new row and removed this multiple values under employee mobile. So this value is now a single value under employee mobile. So all the attributes in this table are now scalar, so there is no multi-value attribute. Then we can conclude that this table is now in first normal form. What are the problems in first normal form? As I told you that this is not the end. First normal form is actually the first step in normalization. We need further normal forms to get our objectives or to remove the redundancy and anomalies in our database. So definitely we will have problems in our table. The first one is insert anomaly. In case of first example, we can't add author with no box. Now if you look into the first example here, we cannot add a new author. If there isn't any book, we cannot add here any new author, but sometimes we need author names. separately, so this is not possible here. And if you look into the second example, we cannot add module with no text. Here we have some modules, so you cannot add M6, let's say, if there isn't any text, so it is not possible here. And in case of third table, a third example, we can add city, the address, with no employee ID. So here we have the address attribute. So here suppose we need let's say Karachi here, so it is not possible to be added in this table because we need something here, also something here, so it is not possible. But practically we may need the list of cities instead of the list of employees. Similarly, in case of update anomalies, if we want to change the price of balloon, we need to change the 3 rows. If you remember, due to multi-values, we created 2 new rows for this balloon, so we must change the prices of all these 3 rows. And in case of second example, to change the lecturer for M1, we must also apply the update query on second row, like here. If we need to change this L1, then we must also change this one, so it is not possible to apply a single update query on this row. And in case of third example, sorry, this one is example number 3. So if we want to change the address for 102 is actually repeated here, so if you need to change this Islamabad to Karachi, let's say, then you must also change this Islamabad, so you will need one additional update query. Now here in this example we have only one extra row. It is possible that we may get 100 more rows of same record. And in case of delete anomalies, we will have similar situation. For example, if we remove a book, we will also remove the author, so the record of author will be deleted. So if we are going to remove a module, then the lecturer will also be deleted, so it is not possible, because we may want to keep the record of lecturer, and if we need to keep the record of city but we are going to remove an employee, so the record of city will be removed automatically.